Hello, good afternoon students. Welcome to one more amazing session from Infinity Land. This is Suresh, Faculty of Chemistry. How are you all doing? So, welcome to one more amazing and fabulous session. Is based on electrophilic addition reactions, and the majority of the reactions of alkenes is the electrophilic addition reactions we are going to discuss in today's class. And this part is going to be the core part of the total any organic chemistry conversions. And what is the details about the electrophilic addition reactions? I am going to present to you in today's class, and moreover you are going to get direct one question based on this electrophilic addition reaction. You know? Fine. So before going for this, a short introduction about what Infinity Learn is doing for the students preparing for the NEET examination. Let us focus here. I just want to show you 4 students for your motivation, bachcho. Ashrita, Akil Verma, Himadyuti and Satyanarayan who got very less marks when they attempted the questions and the NEET examination in 2023, and they attended the class with Infinity Learn, and they followed the sessions like you. And in 2024, how they scored, you can see it is an outstanding performance. The score is almost doubled. Yes, it's true. And you can see Ashrita, she got 310 marks in 2023 and 661 marks in 2024. She got 351 marks increment. And you can see Akil Verma 313 and 658 in 2024, 345 marks increment. Yes. And you can see Himadyuti also got 310 marks like Ashrita and 652 marks in 2024. You see how the increment 342 marks increment, and Satyanarayana got 320 marks increment. This increment, what makes this score is almost doubled. First, undoubtedly they did a lot of hard work like you, and they followed the suggestions, the lessons, the methodologies given by the eminent faculties from the Infinity Learn like you. And our ethnic Mahendra Singh Meena. Hello Mahendra Singh Meena. So let us follow the lessons, and you will be the next for 2025 examination in this slide. I will reserve a slide for you. Ready for that? Okay. Now let's see, for anything you all preparing for NEET examination, so only one determination is there in the mind, just crack NEET. How? Every day we are coming up with one topic, and Monday से new program चल रहे हैं, and we are going to discuss 1000 multiple choice questions NEET में आने का ज़्यादा संभावना निकालने वाले हैं. Okay, so we'll discuss that and attend those sessions, and please like the sessions and share with your friends. And I just want to say, in the Infinity Learn, we are having Infinity Learn Meta app where you are going to see live classes, mock test, create your own test, and 24/7 doubt resolutions. And you can see Infinity Learn is on the social media, say Telegram channel we have. In the description box, Telegram channel link is there. You all just click it and join it. And उसमें क्या मिलेगा? हर सेशन का डेली स्केड्यूल्स भी मिलेगा, डेली क्विजेस भी मिलेगा, एंड सेशन नोट्स एंड असाइनमेंट्स एंड मेनी मोर. डिस्क्रिप्शन बॉक्स में लिंक दिया, एक बार जस्ट चेक इट एंड यू जस्ट फॉलो इट. एंड ऑल्सो आजकल आर्टिफिशियल इंटेलिजेंस का हलचल ज़्यादा चल रहा है बेटा. So what AI is doing for Infinity Learn is the first edutech platform uses AI tools for the academic drive. So in the QR code it is there, you just click it and just enjoy it. And what are the things you are going to get? Goal settings and skill enhancement programs, and awesome lectures by the eminent faculty, and live classes, and you can say test paper analysis, in-depth performance analysis and everything. And you can say self-study, learn, practice, and the conceptual videos, mock and practice tests and flashcards. And also at last but not least, you are going to see doubt resolutions by 24/7. Any doubt at any time, your doubt is going to be resolved a single click away. Why late? You just scan the QR code. Just scan the QR code. Now going ahead, here the last two slides for you before we go for the context. And in that you can see India's largest scholarship examination, score examination. This score examination, why I say it's India's largest scholarship examination, because this examination can provide you scholarship worth of 1 crore rupees and study setup and laptops also, and you will be having educational allowances and up to 100% scholarship. And while late in the description box, the link is available. You just click it and fill the form and enjoy the score examination. You have the score examination, and this is purely online. You can sit at home and you can write the examination. All the best, my dear students. Array, you may be a student of Infinity Learn, or you may be a student of any other institute or school. You can still able to write the examination, है ना? अच्छा बात है. All the best. लिंक है डिस्क्रिप्शन बॉक्स में, एक बार दबाओ. ओके, right. Okay, right. So some technical glitches. No, I think it is, are you all able to see me, can hear me, right? And last slide before the topic, I just want to talk about NEET 2025 All India Test Pack and Test Series Pack, you can say. Whenever you are preparing for any examination, it is required, and where you are standing, how you are doing. That can be done by using just by using a proper assessments. What is this assessment here? This test series pack is scientifically designed by Infinity Learn, where you can see 27 AITS examination, उसमें 13 unit test, 4 part test and grant test based on NEET pattern, and you can see 20 online NEET full syllabus mock test, and 25 NEET topic wise FAQs, and 3 physics, chemistry, biology books along with video solutions on the app, and detailed solutions and performance reports for every test, and benchmarking with Sri Chaitanya students on the rank prediction and proper analysis. इतना सारे फैसिलिटीज इंडिया में कौन देंगे? सिर्फ इन्फिनिटी लर्न आपको दे सकते हैं. इट्स कॉस्ट इज अराउंड 5,999 था. व्हेन यू अटेंड, when you write YouTube 50 coupon code, you are going to get for 2,999, and it is a 50% discount, limited period offer. Everybody just check it, and in the description box also it is available. You click it and you are going to get the awesome package. Okay, Shabiro, hi, how are you? Very good, hello. And let us start with the topic of the day, electrophilic addition reactions of alkenes. It's very simple, and you are going to see halogenation of alkenes is the first example I just want to say. So this is an alkene, general scheme of reaction. When halogen is added to here, the halogen could be chlorine, bromine, iodine. When it is talk about the fluorine, actually fluorine reactions are not studied on par here. The halogen is going to be added here. So halogen is added, so it is going to be 1,2-dihalo compound is formed, and this is highly stereospecific, and it is anti-addition. What is the meaning of anti-addition? The addition is taking place, opposite sides of these double bond is called as anti-addition. It is stereospecific. Okay, so let's see the mechanism as well. When you talk about this pi bond, this pi bond is loosely bounded, and it is going to be added with Br2 in CCl4 as a solvent, so that when the pi bond is coming close to this bromine, bromine is going to be polarized to be Br plus and Br minus, so that you are going to see the departure of Br minus. So the electrophilic part of the bromine is added to give a cyclobrominium ion. A जो cyclobrominium ion, you can also say halonium ion, is going to be a non-classical type carbocation. This is a non-classical type carbocation. Now जो bromine है ना, ये इस तरफ आके पीछे से काटना है, it has to attack from the back side, therefore the bromine is going to be added here from the back side, so it is going to be anti-attack. So this is an electrophilic attack. First is rate determining step and slow step, and in this slow step है ना, and electrophile is being attacked, therefore it is what is called as an electrophilic addition reaction. So let's see here example, और एक example ले सकते हैं आप. So methyl cyclohexene, you are going to see the formation of a halonium ion. So this is an electrophilic attack, it is a slow reaction and it is going to be RDS. What is RDS? Chat box में जल्दी फटाफट देके देना. What is RDS? Rate determining step. उसमें ये मिथाइल ग्रुप इस तरफ आ सकते हैं, जब ब्रोमीन साइक्लो ब्रोमीनियम आयन मिल गए इलेक्ट्रोफिलिक अटैक, ताकि आप Br माइनस इस तरफ आपको आगे से काट सकते हैं, पीछे से काट सकते हैं, पीछे से काट सकते हैं. So when Br minus is attacked in the nucleophile, you are going to get a Br anti-addition. It can also be done in that other way. So when you talk about these two, you are going to see the formation of two and a mirror image like product. दोनों आने का संभावना है. So that the pair of stereoisomers, pair of optical isomers which appear mirror image to each other are called enantiomers. Okay, for that what is the intermediate? You are going to see it is an anti-addition. First of all, you need to know about this, and attack more substituted side, attack with H minus, so that it is a non-classical carbocation is formed. So what are enantiomers? अगर कुछ डाउट है ना तो जल्दी जल्दी पूछना. और एक एग्जांपल दे सकते हैं इसका. सोबिरो. Okay, और एक एग्जांपल है. Reaction with interhalides like ICl. So chlorine is more electronegative than iodine, so that it is going to have partial negative charge, it is going to have partial positive charge. उसमें पहले iodine add करना, so that if this is an alkene, you can see, so I plus and Cl minus, so I plus यहाँ पे आ सकते हैं, and it is going to give ये cyclohalogenation ion. So in this cyclohalogenation ion, and Cl minus can attack at the position A of the cyclohalogenation ion or position B. So if this is attacked at the position A, you are going to get iodine on the position B. This is one product. Okay, if the reverse is taking place, it is not possible. So you got the product like this. In this product, you can say there is a chiral center. It's not a chiral center, but here it is a chiral center. Okay, so that here it is not a chiral center because of this chirality, because this is the chiral center, you are going to see the enantiomers. This is not the chiral center indicated. So I just want to say this is your chiral center beta. ठीक है? This is your chiral center. Understand? And और एक example दे सकते हैं हम. Whenever here benzene, pH stands here, it is a benzene. pH stands here, it is a benzene. It appear like this. Okay, it is an alkene when iodine is added. So you can add chlorine, you can add bromine, and you can add iodine. Okay, so that you are going to see what is the product. First of all, iodine is going to form electrophilic addition reaction. So it is a rate determining step. So you are going to get cyclohalogenation ion. Now what I mean to say, I minus can be attacked at this place, or I minus can be attacked on the other side. Nucleophilic attack दोनों तरीका हो सकता है. So if it is attacked here, you are going to see the nucleophilic attack and the opposite side, so that it is a formation of, it is a chiral center. You can see it's a chiral center. It's a chiral center. You can see hydrogen भी है, so it is also a chiral center. So enantiomeric forms are going to be formed. So two fractions you are going to get it, right? So pair of optically isomers which are non-superimposable mirror images are called enantiomers. In this structure you can see enantiomeric pair. So I just want to say, is it required to make a mechanism? Of course yes, and of course no. So in the NEET examination kind of things, by looking at the product you can have a command on the mechanism and you can write the product as well. Okay, now आगे बढ़ते हैं. So I just want to say a trick. If it is a trick, trans isomer, when it is Br2 is added, you got a meso product, and a cis alkene on Br2 addition you are going to get enantiomer. So what is this? I just want to give you a trick, ATM and CAR. So what is the ATM and CAR? Everybody stay tuned, I am going to tell you, this is a super awesome trick. I will write it here. So what is ATM here? ATM. ATM stands for anti-addition to transalkene gives meso product. Now what is this? CAR. So ATM rule and CAR rule. Here cis alkene on anti-addition gives racemic mixture. That is a trick. According to the trick, ATM stands for anti-addition to transalkene gives meso product. Cis alkene on anti-addition gives racemic mixture. You can see. That is the reason why cis alkene gives racemic mixture. You got a pair of enantiomers is pair of enantiomeric mixture is a racemic mixture. Racemic mixture is optically inactive due to external compensation. If it is a D isomer, it is going to be L isomer. Are you getting or not? Clear? That's perfect. And transalkene, this is a transalkene, you are going to get a meso product. How it is a meso? You are going to see the plane of symmetry and meso compound is optically inactive, and this is going to be optically inactive due to internal compensation, right? So ये लाल वाला जो क्या, ये meso product, and this ATM and CAR आपको ज़्यादा काम आ जाएगा stereo specific, because the addition of halogen is going to be anti-addition. Understand बच्चों? Clear? Fine? That's good. Now let's see a trick. Let us see, this is the one. It is optically active compound. It is optically active compound, and chlorine is added in the presence of a solvent. You are going to get a double bond can be formed, a dichloro product in this way and in this way, and these two are going to be still optically active, and these are non-superimposable and non-mirror images. That's the reason why this pair of compounds are called diastereomers. Diastereomers are formed. You have ATM and you have a CAR and diastereomers. Okay. And also, what is the product in this reaction? Somebody can tell me what is the product in this reaction? And this is a benzene group and a double bond, and there is a double bond over here. When it is added in the presence of Br2 and CCl4, in the presence of Br2 and CCl4, Br can be added over here and Br can be added over here. So that what could be the product? So mind it, a reaction anti hoga. This is anti-addition, है ना? That's why it is added over here and it is added over here. So that you can say this bromine and this bromine are on the same side, this cannot be the product. And two bromines cannot be added on the same carbon atom, this cannot be the product. Then actually product kya hoga? So I eliminated two options. Let us talk about the other options. Let us talk about the other options, A option and B option, C option and D option. And among these, A and D options are not suitable over here, and B and C options looks anti over here and looks anti over here. How do you say it's a looks anti? So you have to just check if the R and S configuration. When you talk about this, if this is the structure, it is going to be R iska wajah se, and it is going to be the S, and it is going to be the S, and it is going to be the R. Based on that, it is going to be this versus this. Yeah, option C is going to be the correct answer for this particular question. Okay, and also you can say oxyhalogenation is also a type of electrophilic addition reaction. In this oxyhalogenation of alkenes, this alkene, when it is added with Br2H2O, what happen? Br2 react with H2O gives rise HOBr plus HBr. So in that you got Br plus and OH minus. So Br plus is the electrophile that supposed to be formed. Okay, Br plus is the electrophile that is supposed to be formed. Okay, so Br and OH you have to follow again Markovnikov rule also. It is also anti-addition. So मान लो यहाँ पर Br add कर सकते हैं and OH add कर सकते हैं, or here in the anti side. So this is called halohydrin formation on halohydrin formation or oxyhalogenation. Bachcho, you can see it is highly stereospecific because it is anti-addition. And also it is regioselective. What is the regioselective? In the previous class we discussed about is the follows Markovnikov rule. It's a regioselective. What is a Markovnikov rule? This Markovnikov rule says negative part of the reagent that attaches to the carbon which bears the less number of hydrogens. Less number of hydrogens, hai na? So you are going to see OH minus and Br plus. Hai na? This is the negative part of the reagent. This negative part of the reagent should attack at the carbon which bears the least number of hydrogens. That is what is called as Markovnikov rule. समझ में आ रही है क्या बेटा? अगर कुछ डाउट है ना तो जल्दी पूछना. वंडरफुल सर, लाइक मार रहे हैं, कमेंट में कुछ लिखना है, कमेंट में कुछ भी ना कुछ लिखना है. अर्तनिक महेंद्र सिंह मीना, अर्तनिक महेंद्र सिंह मीना. Right. Very good. आगे बढ़ो थोड़ा. Now the mechanism, first of all we can see bromine is electrophilic addition takes place. It is going to be plus and it is going to be minus. It is removed and cyclobrominium ion is formed and it can be added with a nucleophilic attack. The lone pair of electron present in the oxygen of the water is going to be attacked over here to give rise a protonated alcoholic group. This protonated alcoholic group deprotonate करके आपको halohydrin form होगा. It is, of course, it is Br and OH supposed to be in the opposite side. Hi Soumya. Thank you Soumya Ranjan Shahu. God bless you. And आपको कैसा लग रहा है पूरा कलरफुल प्रेजेंटेशन? पूरा कलरफुल प्रेजेंटेशन कैसा लग रहा है? Thank you very much बेटा. So halohydrin formation, ये mechanism है. I am not going to stop this mechanism here. Just I want to give you 2-3 examples. आपको भला होगा. Okay, right? Okay, आपका नीट का एग्जामिनेशन कैसे चल रहा है सौम्या? सौम्य रंजन, नीट का एग्जामिनेशन कैसे चल रहा है बताओ पहले. ओके, नाउ उसमें एक एग्जाम्पल है. ये एग्जाम्पल में Br2H2O, यू कैन से H2OBr है ना. सो दैट आई वुड से Br प्लस एंड OH माइनस. जो OH माइनस है ना, मार्कोनिकॉव रूल हिसाब से यहाँ पे काटना. सो दैट यू आर गोइंग टू गेट ए फर्स्ट इलेक्ट्रोफिलिक अटैक. You got in a cyclobrominium ion. So the water molecule is going to be added, nucleophilic attack, anti-addition, so that you are going to get halohydrin formation. So halohydrin formation करने के लिए ये एक सिंपल ट्रिक दिया आपको, ये ट्रिक इस्तेमाल करके आप कर सकते हैं. Okay, you are going to get halohydrin in this way and in this way. The answer stereo specifically you have to check it. So it is an anti-addition, Markovnikov rule. So product Markovnikov rule के हिसाब से देना पड़ता है. And OH is attached to the carbon with more substituted वाला, or this carbon of double bond which bears the less number of hydrogens, है ना. And also you can say और एक चीज है, Markovnikov rule can be used if any classical carbocation is formed. ये rearrange कर सकते हैं, ये rearrangement में हिसाब से आपका product नहीं देना, Markovnikov rule नहीं इस्तेमाल करना. Now let us talk about here another example. If that is the case, Br is added here. Yes. Now whenever Br is added, cyclobrominium ion is formed. Now the water molecule acts as a nucleophile. You can add it here. Okay. So that you are going to see deprotonated form to gives rise a diastereomeric forms. You can see enantiomers, diastereomers, the terms comes in this stereochemical aspect, and I believe NEET एग्जामिनेशन में स्टीरियोकेमिस्ट्री का वजह से आपका क्वेश्चंस आने का ज़्यादा संभावना है. अंडरस्टूड बेटा? Now let's talk about hydrohalogenation of alkene general scheme. Addition of HCl, HBr, Hi. It is also anti-addition, follow Markovnikov rule. है ना? And let's see the mechanism. When this carbon to carbon double bond, the pi bond is going to take the positive charge and Br minus dipole moment is तरफ है. So that you are going to see the formation, whenever H plus attacks na, we are going to see the formation of a classical carbocation. आपका मिलेगा ये classical carbocation electrophilic. This is an electrophile, electrophilic attack का वजह से आपको मिलेगा एक classical carbocation. A classical carbocation is sp2 hybridized. It has a vacant p orbital perpendicular to the plane of triangle, so that Br minus यहाँ काटने के बाद आपका मिलेगा Br is added, HBr is added, and it is following Markovnikov rule. Follow Markovnikov rule. Follows Markovnikov rule. What is Markovnikov rule? Let's see the next example. This is the one. Okay. So here it is a hydrogen. Here it is shown as a methyl group. So that H plus and Br minus. So Br minus यहाँ काटना है, hydrogen यहाँ काटना. So to form a suitable carbocation. So that is a generic version. In a generic rule, empirical rule, Markovnikov rule. लेकिन इसका पीछे क्या होगा? It is going to be a carbocation. Understand? Now it is going to be hydrogen is added, a carbocation is formed, hydrogen is added, carbocation. क्योंकि ये वाला ये secondary carbocation है. अगर H plus यहाँ काटेंगे तो H plus यहाँ काटेंगे तो क्या होगा? So you are going to get either secondary carbocation or tertiary carbocation. Secondary carbocation कम स्टेबल है, टर्शरी कार्बोकैटायन ज़्यादा स्टेबल है. सो दैट ये कार्बोकैटायन फॉर्म करने का संभावना ज़्यादा होगा. सो दैट ये पकड़ के Br माइनस है काटेंगे. टर्शरी कार्बोकैटायन इज मोर स्टेबल देन सेकेंडरी कार्बोकैटायन इज मोर स्टेबल देन प्राइमरी कार्बोकैटायन, कम से कम मिथाइल कार्बोकैटायन. एंड Br माइनस काट दो है पर. सो whenever you can see the Br minus over here, Br minus is attacked to give rise this product. Understand? Clear? Any doubt? And Markovnikov rule, H goes to the less substituted carbon and do not go to the more substituted carbon. or otherwise negative part of the addendum or negative part of the reagent attaches to the carbon that bears the less number of hydrogen atom in the unsaturation part. Clear? अच्छा बात है, clear. Now let us talk about addition of HCl. AB कार्बोकैटायन फॉर्मेशन का हिसाब से जाना पड़ता है, कभी कभी रीअरेंजमेंट भी हो सकता है. देखो H plus and Cl minus, this is H plus and Cl minus. Hu plus is added over here to give the corresponding carbocation like this, a tertiary carbocation. A tertiary carbocation, a secondary carbocation, 2-degree carbocation. So here there is a chance of rearrangement, and you can also see a carbocation that can be formed, and that carbocation is actually a primary carbocation. That primary carbocation is not that stable. That's the reason why this will not be formed and this will be formed, you know. And once this is the secondary carbocation can undergo hydride shift to give rise the more stable tertiary carbocation, so that ये वाला Cl minus add करने तो very less minor product मिलेगा, but ये rearrangement करने के बाद आपको tertiary carbocation मिलेगा, it's more stable as compared to this, and you're going to get a nucleophile is going to be attacked over here, so that the major product that is going to form is 2-chloro-2-methyl-1,2,3,4 butane. समझ में रहे क्या? Clear? Wonderful. So what is the major essence of this kind of topics? So mechanism is very important to give the exact product. And stay tuned, one more question I just want to show you. Yeah, more examples. So it is going to get a H plus and I minus, so that a electrophile is being added. When electrophile is added, you are going to get a tertiary carbocation, so that I minus can be added to give its product. समझ में आ रहा है क्या? Any doubt? And also let's see one more. And this is the one where you are going to see direct formation of the carbocation, secondary carbocation. अगर ये hydrogen shift करने के बाद tertiary carbocation within the ring can be formed, and this tertiary carbocation can be attacked with a nucleophile to give rise this product. Okay, and also you are going to expect ring expansions also. So this can be expanded its ring to give rise to different products. So that is called Wagner rearrangement, bachcho. And you can also see this is benzylic carbocation can be formed. This benzylic carbocation is super awesome carbocation, so that it is going to be Br minus is at, so that this is the actual product. And if you want to go with the other side of the carbocation is not, this is just sirf secondary carbocation, but it is a secondary benzylic carbocation. Like that, n number of examples, so we can go ahead with that. अगर कुछ डाउट आने तो पूछना. Students who are there, Soumyaranjan Sahu, एनालिटिक्स अच्छा देख रहे हैं. नीट एग्जामिनेशन का पढ़ाई कैसे चल रहा है बेटा? अर्तनिक महेंद्र सिंह मैना एंड सोबिराव. ओके, आगे बढ़ते थोड़ा सा ज़्यादा एग्जाम्पल्स देने के लिए, ठीक है. नाउ hydration of alkene. Addition of water to alkene is called hydration. So water is added in the presence of an acid catalyst. So water can be added to alkene by 3 methods: acid catalyzed hydration, hydroboration oxidation, and oxymercuration demercuration. 3 major reactions. Okay, first let us see the acid catalyzed hydration. When you go with an acid catalyzed hydration, is anti-addition. H2O means H plus and OH minus, so that H plus can be added here, OH minus can be added here, classical carbocation can be formed, so that rearrangement can be formed. Let's see the generous mechanism for that. So H plus and H2O in the acid catalyzed hydration, H plus comes from H2SO4 or any strong acids like syrupy phosphoric acid, H3PO4, and don't use HCl, HBr, HI, क्योंकि ये HCl Cl माइनस देते हैं and HBr Br माइनस देते हैं and HI माइनस देते हैं, strong reducing agents होगा. So ये reduction रिएक्शन में पार्टिसिपेट कर सकते हैं, न्यूक्लियोफाइल भी तरीका पार्टिसिपेट कर सकते हैं, सो दैट दे आर गोइंग टू ऐड एज अ HCl, as HBr, as HI. They don't go with this acidic medium. Okay, they are not providing an acid kind of the. Here H plus is an acid and it is a catalyst and it can be regenerated better. ठीक है, it can be regenerated. Let's see the mechanism of this. So mechanism, first H plus is added, which is coming directly from H2SO4. H2SO4, it is coming to give rise H plus and HSO4 minus. Okay, so this H plus जो है ना is going to be added to the alkene to give rise corresponding carbocation. This corresponding carbocation, if chance is given, they may rearrange, or otherwise we can see this carbocation formation of an electrophile first. Okay, let's see. So H2O is going to take the H plus from this sulfuric acid to give rise H3O plus. Okay, pKa of this is 14 and pKa of this H3O plus is going to be 0, so that it is going to form, the reaction is going to be favored in the most forward direction better. Okay, now you are going to see example, what are the products that can be formed. Can you say what is the product that can be formed here? Bachcho, take a minute and try to do this. Take a minute and try to do this. Acid catalyzed hydration. So what exactly happened? First of all, formation of an electrophile. Yes, we got the electrophile that is formed, and that electrophile is added to this alkene, so that a protonation takes place. A protonation takes place at this place, okay, or at this place. If it takes place at this place, it is going to be carbocation. If it takes place at this place, it is going to be carbocation. Two probabilities are there. Formation of this secondary carbocation less probable, formation of this tertiary carbocation is more probable. So this is the actual product intermediate that is going to be formed. You have to check it. So a stable intermediate can give you a stable product. A major product is always formed from a stable intermediate form. So this tertiary carbocation is going to be added with water molecule. The lone pair of electron present on the water is acting as a nucleophile, is attacking over there, and protonated alcohol is formed, and it is going to deprotonate to give rise the corresponding major product like this. Never by heart anything. So inculcate the methods. Inculcate the methods. समझ में आ रहा है क्या बेटा बच्चों? वेरी गुड. अगर कुछ डाउट है ना तो जल्दी से जल्दी बोलना. चार्ट बॉक्स में मैसेज फटाफट डालो. चार्ट बॉक्स में मैसेज फटाफट डालो. Now Markovnikov rules, HX. So X goes to the more substituted carbon, H goes to the less substituted carbon. मान लो ये HX हो सकता है, HOH हो सकता है. ये positive part of the reagent, negative part of the reagent, positive part and negative part. Okay, it follows Markovnikov rule. Simple, without rearrangement we can say. समझे? Sometimes rearrangement can also be possible. If carbocation rearrangement भी है, and let us see the mechanism. Anybody can write the mechanism for this? Write the IUPAC's name if you know the mechanism. जल्दी फटाफट कर दो ना बेटा. सौम्य रंजन साहू, पढ़ाई कैसे चल रहा है बेटा, समझ में रहे हैं, मज़ा आ रहा है क्या, ये मैकेनिज्म में। ओके चलो, यहाँ पर H3O प्लस प्रोटॉन ऐड करने के बाद यू आर गोइंग टू गेट ए सेकेंडरी कार्बोकैटायन। दिस सेकेंडरी कार्बोकैटायन हाइड्रेट शिफ्ट करने के बाद आपको टर्शियरी कार्बोकैटायन मिल गया। This tertiary carbocation is safe, more stable, and the electron pair on the oxygen or the water molecule act as a nucleophile, and this nucleophile is going to take a protonated alcohol बना, and a protonated alcohol deprotonate करने के बाद आपका final product ऐसे बन सकते हैं। And you can also go on the other way, Wagner rearrangement में आपका ring भी expand कर सकते हैं। That is another way of discussion, ठीक है। And also you can see yes, challenge questions. This is a challenge question. Who is going to answer this? Who is going to answer this? So probably this is the last question for this. जल्दी लिखो। Okay. So, Soumya Ranjan Sahu, if anybody knows the answer by writing a proper mechanism, I am expecting you to give the answer in the chat box. आप अगर एक क्वेश्चन कर सकते हैं, आपका आंसर चैट बॉक्स में फटाफट दे सकते हैं। नहीं चाहे नहीं जानते हैं तो आप बोल सकते हैं आई कैन गिव यू द आंसर। नाउ दिस इज एन alkene. When the proton is added to this, you are going to get a carbocation, and this secondary carbocation यहाँ से ये जो अल्काइल ग्रुप देख रहे हैं ना, ये अल्काइल ग्रुप यहाँ से यहाँ तक बदलने के बाद आपका टर्शियरी कार्बोकैटायन मिला। दिस टर्शियरी कार्बोकैटायन न्यूक्लियोफिलिक अटैक ऑफ द वाटर का वजह से यू आर गोइंग टू गेट ए प्रोटोनेटेड अल्कोहल। ये प्रोटोनेटेड अल्कोहल में ये हाइड्रोजन हटा देना था, आपको मिलेगा ये फाइनल प्रोडक्ट है, मेजर प्रोडक्ट। इसका आंसर क्या होगा बेटा? लेट मी जस्ट से 1 2 3 4 5 and 6. This is your methyl group and this is your ethyl group. So that is going to be 3 ethyl, 4 methyl, hexane 3 all, और क्या सिंपल बना सकते हैं ना? Very good, clear. Now, as you can go with another one, predict the product of the following reaction. When HBr is added, this is the one. You are going to see the formation of H plus is added here, a benzyl carbocation. This benzyl carbocation is super stable due to resonance. So Br minus is attacked here to give rise the product. ये भी बना सकते हैं so that it is a chiral. So you are going to get a pair of enantiomers. 50-50% mixture of pair of enantiomers is called. It is a racemic mixture. It is optically inactive due to external compensation. Okay, और क्या? Now, in this particular one more example I can give you. When H2O and H2SO4 is added, you are going to get a formation of an electrophile, first step, and it is going to react with an acid to give rise the corresponding a secondary carbocation. यहाँ पर carbocation आना है, so that water is added to give rise the corresponding alkane. Here it is achiral molecule and it is not optically active. You all just check the various types of examples and a colorful mode I am giving you, है ना? Very good. So बच्चों, in today's class we have seen various types of electrophilic addition reactions that are participated in the alkenes. So based on this, you practice so many questions that I am going to post in the Telegram channel. Okay, thank you very much. You hope you love this session, and please like the session and share with your friends and subscribe to Infinity Learn NEET YouTube channel. And stay tuned, every day I am coming up with some topic, and Monday से आपका NEET sure short multiple choice questions भी discuss करना है. Okay, thank you very much. Signing off, Suresh, Faculty of Chemistry from Infinity Learn. Bye bye.